Hello, welcome to this new video on QuPath. So recently I had a user asked me to identify cells that are both positive in green, red and maybe another channel. So basically multiplexed analysis. So I've already done a video on this topic, so I thought that I would spice things up a little by adding density maps to the mix, and also something that I consider a bit more important, which is how to properly train your models using unbiased, or at least the most unbiased way possible to do that. So this is the result you should get at the end of this video. So without further ado, let's start over with a new project. So as usual, you create a project by creating a folder. So let's just put this on the desktop and create quickly a new folder. And let's call this new folder. Okay, here I don't want to save this, it's okay. Oh, well, just save it. So let's just reset everything to the default classes here with this new project. I can close this window here and let's add some files. So I have some images here taken from a slide scanner, so let's add them here and set them as fluorescence here. Click on import and they should show up here in the project tab. So let's have a quick look on those images. Let's open up the first one, and as you can see, the default display settings are not that well done, so let's just do some quick adjustments here. So we will work one channel after the other, and here how should we proceed? Let's double click here to increase a bit the minimum display value. Maybe we can increase this one instead. Let's try this. That's a good starting point. I mean, we are looking for stains that look like those bright dots here in this channel anyway, so we don't need to have too many details. So we can do the same quickly with all the four other channels. So let's try something like this again. Yeah, so here, since the signal is very low, that's why I'm using directly inputting number here in those fields instead of using the sliders, because it's a bit too complicated to do that. If I want to do that, it's pretty harsh, although here I got by chance a good result. But anyway, let's start here with 250 and let's increase this a bit to 1000. Looks a bit better. And finally the DAPI channel. Here I think 50 is okay, but here it's a bit too high. Let's try this. Oof, too harsh. Yeah, let's do it by hand since we have quite a lot of margin anyway. So here, if I display everything again, you should get a good idea on how your this slides should look like. And as you can see, all those cells have a wide variety of staining, and what you want to do is train first, find the right parameters to detect those cells, and then train the models to see which cells are positives in AF647, AF505, and AF488, and also all the combinations, of course. So if we check the other image, let's save this here, with the current display settings, the AF647 is way too high, so let's just change this a bit and just use this one as a reference, since I find it's a bit more interesting. So the main point of this topic is not the multiplexed analysis, since I've already done a video on that, but how to proceed to create a nice and unbiased training image. So usually what you want to do is try to get out of the picture any human input if possible. So in order to do that, there's a tool here in classify training image, and let's say if you have really a lot of images, you could split your project in train, validation, test subsets. This would be the ideal case, but most of the time it's not like that. And so in order to have something that can be used as a proper training image, we have to create region annotations first. And within this tool, you can set up here the size of the region you will create. You can give a classification automatically to this region and choose how the location of this region will be set. So by default, I guess it's viewing center or image center. Here we want to use random. But before we do that, let me just get back quickly to the annotations, and here I will, by using the right click tool, add a new class. So I want to create a specific class just for this, to avoid any further issues, because I know QuPath is quite sensitive to the naming and classes that are used afterwards. So let's start with this to get this over first. So training, and let's show properties. Where is it? Let me just double click on it. Yeah, just to change the colors. I want a bright red color for those regions. Okay, so moving on, we go to training images and create region annotation. 500 by 500 microns is okay, considering the size of this slice here. So let's set up the classification to training, and let me get a nice overview of the sample here, and we can click here on create region. So as you see, each time I click on create region, it will place randomly regions across the image. So I will click a few times more unless I get at least, let's say, 6 or 7 regions within this sample, and I will get rid of all the regions that I find are completely out of the slice itself, because they are not really useful. So I can close this here. Let me just quickly double click and delete those regions which will not help us. I want to keep at least a few of them which are touching the borders there, but the other ones will just enlarge the training image unnecessarily. So once we've done that, we could just leave it as it is and start to build our training image using those random regions. The problem is, if you want to be really thorough, what you need to do is use another image, or maybe several of them, just to be really complete and not be biased towards, this time, the sample itself. So let's just change the image right now and keep the same procedure. I want to save the changes, yes. And here, without changing the display adjustment, doesn't matter that much. Let's go to training image, create region annotation. We keep the same settings and create a few more regions there. So I guess this should be enough. So again, let's just delete those regions which are out of the picture, like that. This should be okay. So now that we have defined our regions, we can go again to classify training images, and we can create the training image itself. So to do that, we want to look for all the annotations that have a specific class. So that's why I've defined this training class. So let's select it. The preferred image width, so this is the maximum image size. The problem is that you will get a stripe of squares stitched together, so you will have a very long image, and at some point it will be not that convenient to handle. So that's why you can limit the size of it here. Rectangles only. Those are already rectangles, so we don't need to. Doesn't matter that much. So let's just press OK. And let's save the changes here. And now we are automatically switched to this sparse image. This is interesting. You can see here it has taken only 6 regions. Why? Because I didn't save my changes before creating the training image. So the only regions available were the 6 from this image. So let's just set this to fluorescence. I click OK. You get the idea of what you will end up with as a training image. But we want to really have all the images. So let's start over. I can remove this image here. Sorry, to do that I need to go back to this one. Yeah, we can save whatever here. Yeah, I also want to delete all the associated data and create again the training image, like here. Press OK. And now we have more regions, exactly what we want. So it's a fluorescence image, and here, as you can see, it's a nice collection of samples that we can use to train our algorithm properly. So next step to train our models is to create different images for each of the channels. I've already explained that this is typical to the multiplexed analysis. When you try to create a model for a specific channel, you have to use annotations that cover those positive regions, and another class which should be background or something like this. But this background class is actually specific to the channel. So while you use it at the same time for all the images, you cannot use it on the same image. That means you have to split the image into its different channels so that this background class is actually specific to the channels and not the same for all the channels. Okay, so in order to do that, with this sparse image selected here, I go to classify training images, and I will create duplicate channel training images. And I want all the 4 channels here. For some cases, you can use point annotations. Here I won't use that because I want to actually train the cells I will detect. So for me, it's a bit more convenient to not use point annotations. So press OK, and you can see my sparse image here has now been split into 4 images. Actually, when you switch to an image, you have to select again what type it is. It looks exactly the same. It's just that all the data will be specific to this image. So the models, the cell detection, etc. So this allows us to keep things neatly separated. So it's a good practice to do that. So the first thing we have to do now is detect the cells. So let's just show only the DAPI channel to see the nuclei. Let me just zoom in a bit on the image. Sorry, I have to uncheck this here. So this is how it looks like. And in order to detect the cells properly, so I have a nice collection of the different types of cell I will see across my slide, I will automatically create an annotation for the whole sparse image. And to do that, I can go to Object, Annotation, and create full image annotation, like that. And then I have to go to Analyze, Cell Detection, and click again on Cell Detection. And here I have to find the right parameters to display correctly the nuclei. So let's try with the default and see how it looks like. So by the way, while it's doing that, I will stick with the basic cell detection because I found out that it works quite well. We don't need to use extensions like Stardist or something like that. Here it's just enough to do the detection properly. So we have many cells here. We can switch them on and off, and by default the detections usually are not filled. They look like that, and we can change the opacity here a bit like this. So with this view, it's quite useful to see. So what I see right now is that the cell expansion, which we will need, because I didn't show that, but on the slices here, we have some staining that is outside of the nuclei, and we want to classify this, so we need this information. So we need actually the same expansion, and 5 microns seems okay to me. But here we have very small objects, which is a bit difficult to consider as cells, and here those are very dim. So if we want to set up the threshold, for instance, you can look at the value here down at the bottom of the screen on the bottom right. And if I hover over a cell, for instance this one, we can see the value is 507, and here it's 800. So we can safely increase this value a bit. Let's use something like 250 and run it again, and let's see if it's still detected. So as you can see, we got rid of those dim cells. Now we want to maybe increase a bit the minimum area here to also get rid of the smaller cells. So to get an idea of the size of the nuclei here, I don't know, maybe use this one here. We can go onto annotation, and we have already the statistics here. So nuclei area is 13, so that's why it's included, because we had a minimum value of 10. So let's increase this to 15, and let's try again. But before doing that, I need to unselect this object, so I can go to Object, Select, Reset Selection, and then Run. Process all annotations, yes. Let's try again. Okay. So now the very small nuclei here are not part of my detection. So let's have a look at the rest of the sparse image to see how it worked. I mean, I think this is okay, but it's up to you to decide if on your own sample those parameters will work. At least you get the idea on how to proceed. So since those parameters are okay for me, what I want to do now is to keep them, to be able to reuse the same settings on all the other images. So in order to do that, I will go to the workflow tab here, and I see here a list of all the commands I've used and that can be used for the scripts. So let's just click on create script here directly, and I want to keep only the last one, since it's the last cell detection that I viewed that was correct. Get rid of everything else here, and as you can see here, I've already have some other scripts, but let's ignore them for the moment, and let's save them as my cell detection, like that. Okay, so now we've defined a nice way to detect the cells. The next step is, let's go back to project, is switch to this time the green channel and start to build our models step by step, one model for each channel. And then we will create a composite model, composite classifier for all the channels. You can save the changes here, and here it's a fluorescence image. Okay. And let's change the display settings to see the green. We can keep the DAPI for the moment, it's fine, I guess. And let's create the full annotation again and start to detect the cells. And to do that, I can go now to automate project script, and I see here in my project script my cell detection. Let's use that. Click on run and run the script. So obviously I get the same cells as before, since it's the same image. And by the way, if you want to be really thorough, you will create sparse images for each of the cases. So for instance, I would use other regions, other training regions, to create another image for the AF48 channel, another image, and so on. Well, I mean, this gets a bit complicated and it's maybe overkill. So I think what I did here is unbiased enough to have robust classifiers. So let's close this window here and let's see how it looks like. Seems nice. So let's go back to annotations here, and what we want now is classes that represents our channels. So in order to do that, we can click here on the small three dots and click on populate from image channels. Then it asks us if you want to keep the existing classes available. We don't need them anymore, so click on no, and we have now all the classes here. So currently they are hidden. Let's show all the classes here. This is because I've used the software before, and so by default they were hidden. And here I want to show them. And now using this, I will make sure that the regions I draw will be associated with the correct class. So there is this tool here, which is, as usual, as I said always, is quite dangerous to use, because you forget that you have set it to auto set, and so each time you draw something, it will grab the class that is currently selected there. So either you want to do it the hard way and click on set class each time you draw an annotation, or you press on auto set, but then you have to be careful and think of how you will proceed to not forget that it's enabled. So anyway, auto set is clicked, AF488 is selected, and now I can use my brush tool or click on the B key to select it automatically. Usually I don't talk that much about shortcuts, but here, since we would constantly switch from the brush tool to the move tool, or hand tool. Actually, it's B and M on your keyboard, so you can just click on B, M, like this to quickly switch from one tool to the other, which is quite nice. So what we want to do now is color the regions. And one trick where the green channel is positive, and one trick I find quite useful also to maybe not be that biased again, is to just switch off the display of the cells. That way you will really not take into consideration whether the annotations you are drawing are on cells or not. So let's start to color some regions like that. Everything that I consider as positive here will look as positive. So let's use the move tool to change here and select a few more. This is positive for green, this also, this also, this also, and so on. This, like that. So we have a bunch of annotations here. Let's see. Maybe we can take another one into account here, like this, this, and this. So we have a variety of different cases here. Maybe here also. So like that. And now we will switch to the other class, which is ignore, and we will draw regions that we consider as part of the background, like that. So it's important to include so like that all the cases you will find. That's why this sparse image is so useful for the training, because otherwise you will probably stick in the region you consider interesting for you and avoid the regions that are not. But the problem is that you will probably create a model that is not that robust enough. So I think this is enough. Let me just zoom back here, and let's find our square region here, and let's try to see now with the cells enabled the classification. So we can train a classifier here by clicking on classify, object classification, train object classifier. And since currently on this image there are only two classes that are used, the green one and the ignore one, we don't need to change any kind of parameters there. We can just click on live update, and if we want to fill the regions, we will get a better idea on how it looks like, and also change the opacity like that. So this is a bit better. And looking at the proportion, I think by experience this is quite okay. Let's just zoom in the image a bit. So I don't know why it doesn't zoom here. Again, this is the tool that was checked. So to verify that the classifier works okay, you can switch on and off quickly like that. I think it did a good job. So if it's okay, we can save the classifier and give this a name. So it will be, this case, my AF488 classifier. I'll give it a meaningful name. I usually use the channel name and classifier to see what is this thing doing. So let's save it, and so you can see it's saved. And we will do the same now for the two other channels. So we go back to project, change the image to AF555. I want to save the changes here, and so on. So I will go a bit faster here, since it's exactly the same procedure, although the image looks a bit different. So let's enable AF555, create the full image annotation, launch my cell detection script. Okay, and go back to annotation, select this time AF555, the brush tool, hide the cells, and off we go. Create quickly some positive regions there. Here also, like that. Okay. So I won't be that precise in this case. Let's switch to ignore brush, because you get the idea. This is background, and I think here it's quite useful to select a few more. Like that. Okay, so how does it look like? Classify, training image, object classification, train object classifier. OG, like that. Is this okay? Too many positive cells, I think. Yeah, let's try to correct this a bit. Okay, this is a bit better. Yeah, this should also be negative. Okay, so this will be my AF 555 classifier. Save this and move on to the last channel. Save the changes here. Fluorescence, okay. Change the display. I want the AF467. Annotation, create full annotation. Project script cell detection. Let's run it. Okay. Hide the cells and trace some positive regions. Here, here, here. This is positive, this is positive, and this and this. Okay, like that. So let's use ignore. So those are definitely not positives. Those are not. Those have too few staining. Let's see. This. Something like that. Okay. Sorry. Like that. Select the whole image. Classify. Train object classifier. Live update. And show the cells. How does it look like? Okay, fine. So my AF647 classifier, like that. Let's save this. Okay, so we have now our 3 classifiers for our 3 channels. What can we do now? We can go back to the sparse image here. Save yes. And we can maybe create our composite classifier on this image and then apply it on the on one of the samples there. So let's try this. So in order to do that, I need again the cells, like I would do for training any other classifiers. But this time, instead of training a classifier, we will go to object classification and create composite classifier here. And here we can see a list of all the classifiers we have used here. So you can see that the order matters. So because the first class will be the first classifier you select, and then the subclasses will be derived from that. So usually you will select first the class where you have the most cells and then use the other ones below. So let's start with 555, the green, and 647, like that. We can give it a name, my composite classifier, like that, and we can save this and apply to have a look on what it looks like here. So you can see we have a nice collection of colors. That means that it worked. Some cells are green, some are orange. The red ones are actually the ones that are not classified or that don't belong to any classes. So now that we have everything, we can just go back quickly to workflow, and just for the sake of convenience, we can go to classification, object classification, and this time use load object classifier. And since now we have saved this one, we can apply the classifier. Didn't register. Okay, so what we want to do is maybe just classify, reset everything. So now nothing is classified. Object classification, load my composite classifier, and apply classifier. Okay, because what I want is here, see, run object classifier. Actually it was there, but anyway. So, and keep this as a command that runs my classifier. So actually what we could do is keep all those instructions here. Actually no, what we want to do here is just keep those two commands here. So the first one is actually the cell detection, and the other one is the classifier we load. And we can save this script as a script which we call my cell detection and classification. So it does the two steps in just one script. It's quite simple, it's just two lines here. Okay, so now we are done. We can test this properly. So to do this, let's open up the last image here, which we haven't seen yet. It's okay, yes. And let me just display all the channels. And let's see, let's say, okay, we want to apply our script on a specific region. So as always, you can define the regions like you want, for instance, a square here, and then you can refine this region by using different means. Here I will use the wand tool and the Alt key to, sorry, why does it work? If I click on the brush tool does it work? Why is it locked? Interesting. Did I do something wrong? Normally I should be able... Oh, it's because it's probably protected. Yeah, okay. That's... See, I told you, AutoSet is a very dangerous tool. Let's just delete this region again and start over. So now this is just a rectangle annotation, and normally I should be able to edit it with the Alt key. Yeah. Okay. Why doesn't it work? Okay. Let's try again. This works. Doesn't. Select this region. Alt. Okay, now it works. It's a bit capricious sometimes. So use the wand tool here. Well, I just want to get rid of this thing here, like this. Okay, now it works properly. So that I get a clean segmentation here of the borders, but I get this area here. Anyway, now we can click here on automate project script, my cell detection and classification, and run the cell detection and classification all in one step, like this. Hopefully it will work. There's nothing fancy. The region is a bit bigger than my sparse image, so that's why it takes more time. And here we go. So we have a nice result here, which is a bit difficult to see what's going on. So in order to see a bit better what's happening, let me just hide. Let's just keep the DAPI channel, for instance, here, and hide all the other channels, so you can see a bit better what's going on. And if you look here at the annotation, we have here a list of all the detections. So we have 16,000 cells detected, and here we have all the classes and subclasses. If you want to, for instance, see the triple positive cells, we can display them. So I will show here in the classes panel, populate from existing object this time, including the subclasses. We can keep the existing classes, yes. And the triple positives here are currently pink, which doesn't stand out that much. Let's switch that to a bright yellow. And for good measure, let's hide the ones we are not interested in. So we can hide the class here, or you can just press on H, hidden, hidden, hidden. So we see all the cells and the bright yellow ones. And so this is a good way to visualize where are located all the triple positives. And you can see that those cells which are positives in all the three channels are mostly located in a specific area of the slide. So that's quite nice. And now, before we finish this video, I wanted also to show you quickly how to use this density map feature. We can create here in the Analyze menu, go Analyze Density Maps, create density map. And by doing that, we have a menu here, a small panel, and we can choose the main class, and here choose the triple positives. And you can see that those are really located here. And what we can do now is change the density radius like that, but usually by default it's okay. What we can do is actually create automatically an annotation based on this density map. So we can save it, and say like my density map to keep the same nomenclature. Let's save it, and now we have enabled those buttons here, and we can click on threshold here, and you can see here that threshold allows us to define the region here, and we can press on apply, and now I've created a new annotation here, and if I set the properties here, I can give it a name, and I can say here high density of triple positives, like that. Okay, and now the name appears here, and we can now close the density map tool, and now the map disappears, but we still have the region that we have defined. And so now we know on these slides where is located those triple positive cells. This is a nice way to do an analysis, and since we didn't draw anything manually besides this region, but we could have done that on the whole tissue here, but it would have taken too much time. That's why I've limited this here. We know now, without any manual input, where are our triple positive cells, which is I think the best way to do this kind of analysis. Okay, so we're done. If you have questions, as always, you can write me directly or leave a comment. Don't hesitate. And thank you for listening. Bye bye.